record. Okay, so basically, we're gonna learn the Verilog as one of the hardware description languages. So what other languages you guys heard about under the hardware description languages? Have you guys heard about it? Have you guys explored what does hardware description language mean?
There's also System Verilog.
Correct. This is System Verilog, which is the upgraded version of Verilog. You're right. What else? We have Vhdl. Yes, we have Vhdl. Let me see the chat because I cannot see the chat for you. Vhdl, you're right. So we have the Vhdl, and you have to know that Vhdl is the baby of the Air Force. So the Air Force people, Air Force folks, the one who built and designed and developed Vhdl. Verilog and the system Verilog is mainly used by industry like Intel, IBM, all of the silicon industry around Cal Poly and outside Cal Poly area, and so on. So anyway, the differences between of them is not that really huge. If we have time, since we have 15 weeks, I might share with you also what is the difference between Verilog and the rest of the other hardware description languages. There is something else you need to learn, which is called mixed languages. In a way that, if you have a certain specification for a problem and you are trying to solve this problem by making a design using hardware description language, you can actually combine those three languages together. Would you imagine that? So you will write a piece of the hardware using Verilog, and the other with Vhdl, and other with system Verilog, and you will combine them together in one design, and it will work. You will get the benefit out of each of the language, and they call it mixed languages. Okay. So if we go back, to see the online with the course descriptions, so the course will allow the student to explain timing diagram for latches and flip-flops, and explain how these devices behave differently. Furthermore, the students will be able to design combinational circuits, finite state machines, shift registers, counters, data paths, control of a typical system like a CPU, sequential multiplier, sequential divider, traffic light controller, and vending machines using Verilog. After taking this course, the students will be able to explain the architectures of FPGA, calculate the maximum clock rate from the setup hold time specification. This is very hard part of this course, so I want you guys to focus. I'm not sure how many of you attended with me 2300. But do you guys remember we talked in something is called critical path, right? Which is the longest time delay between the input and the output. You have to fully understand this. You have to fully understand this because that will help us to determine what is the maximum speed or the maximum clock frequency the circuit can be clocked. That makes sense? So you need to know also this course to qualify to attend this course. You should know the knowledge from out of the 2300 and 2300 lab. And you have to take the concurrent, you have to take a lab of the 3300 with the course. That's why you will do a best. That's why from the point of the perspective, I mentioned to you, I'm gonna have practical part, theoretical part in the lecture. That makes sense? Meeting, we're gonna have Monday, Wednesday, from 11:30 to 2:15, and that's gonna be covered most of the stuff I mentioned. And I will try to give you some recorded videos. I already have it and prepared it before. I will share it in the Blackboard in a very structured way under the week number. Since we have 15 weeks, so you will find under the. Let me show you what exactly you need to find. So if you go here, you will find course documents, right? I will create here 15 weeks. Plus, I will create also folders for the exams like midterm, quiz, and finals and so on. You will be able to see it and access it once it will be loaded on the system, okay? That's gonna help you to go through the lectures. And if you have any question, of course, you can stop by my office hour. But the office hour has a story. So let me tell you the story of the office hour. How can you access my room? Here is the information about the Zoom meeting, and all of you guys did a great job and you attended, right? If you look here more, you need to know my office hours. So my office hours, I already created something. It's called calendly.com. Okay, you will click on this, and from there you can pick up at what time slot you can talk to me. During the office hour, Monday, Wednesday, which is 16, which is I think 4 o'clock to 6 o'clock. That makes sense? Monday, Wednesday. So you can click on this link, and it shows you the calendar. Like, you would like to make an appointment with me, let's say on Monday today, just an example, right? So today is 24th. So, if I click like this, it gives you all of the possible times you can pick up. So be sure that, you pick up the time slot. And then, you will go here and confirm. Then it will let me know in the system that, somebody will talk to me from 4 o'clock to 4:15. Then, in your system, it will show you that somebody took the slot. So you have to pick up the available slots. If not, you already have the 26, if you have the 31, and so on. Later on, maybe I can change it to be 10 minutes maximum for the students, so I will be able to cover all of you. That makes sense? Anyway, textbook. This course, any materials you can use. It doesn't matter, You can use the tutorial coming out of Vhdl. You can use Linux guidance. You can use the digital system design using Verilog, which is a book I have in the office here. Let me find it here. This one. Yes. Okay. Or you can use the Stephen Brown Fundamental of Digital Logic Verilog design, or you can use Rafiq Zaman Digital Logic Microcontroller Edition. It's up to you. But as I'm an instructor, I am actually following this book and other materials I developed by myself. And, of course, you can find the material anywhere. Okay? Then, how are we going to deal with the grade parts and the exams? Okay? So first of all, how many quizzes are we going to have in this semester? We're going to have 2 quizzes and 2 midterms. Each quiz will be having 5% in total grade. And the dates are already designed in front of you. So you have September 30, it's gonna be the first quiz. Then the midterm, the first midterm is gonna be in October 14th, and then the second quiz is gonna be in November 4th, and then midterm exam number 2, it will be in 18th of November. And we have 10% in a project. What is this project is? So I know that most of you have a problem with gathering and making group, right? So I'm gonna send email to you through the announcement part. This is the announcement on the Blackboard telling you what is your group is. So I'm gonna make a group list and I will put you there inside the group. So you don't need to waste your time who's gonna be working with who, okay? Then I will come with a certain list of projects assigned to you. You will work in your project, you will make a presentation to the project, and you will be 100% sure that, to present very well with a team, your work with a very clear contribution list for every single member. Like, let's say, I am doing a project with Mario. Then, I will come and say, the project's work is 100%. I did 40% of the work, and I stated, like, I make the specification, I cleared up that whatever, I make the graph, I write this portion in the report, and I wrote the code by this amount of time. Then Mario will come and say, I did this, and I did that. That will help me to give you the right grade. In the top of this, I will make like a meeting with you while you're making the presentation for me about the project to check clearly who did what. Peter, do you like, my question for you guys, do you like to pick up your group, or do you like you guys me to assign you the group?
Pick up the group.
So, okay, can you do me a favor, everybody? write in the Zoom who would like to assign, who would like to pick up. And then, based on the number, I will decide. So
Also, how many people in the group?
Huh? In the Zoom, yes, in the chat.
How many people in the group?
I'm gonna decide later. But for now, the concept, do you want me to assign or to pick?
Can you assign the ones who don't find their own group?
Yeah, 1 second. Just let me see. Everybody, you already finished writing? You guys finished? Okay. So let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12. Khalid, you did pick twice. That's not fair, I see your name twice pick. That will not affect on my decision. Anyway, so how many?
You got a sharp eye.
Yeah, okay, 1, 2, 2 pick, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 pick, and how many assign? 12 pick. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. Okay, 11, 12, 13, 14, 15, 16, 17. 17 assign. So I'm gonna assign. Okay, so 17 assign, 12 pick.
Professor,
Yes.
would it be possible for you to assign it for those 17 people? And for the remaining one of us, we can choose our groups?
Yeah,
That's really quite hard for me to do,
Project together already, so it would be better to like.
I cannot make custom reconfiguration here. It should be based on rules, right? But can you do me a favor? Since you guys now, all of you in the room with me, right? In the shadowing room, go ahead and make a very 1 second. Go ahead and make a very long list by yourself. Say that I like to assign, I like to pick, and send me the list.
Okay. You want to send it in the chat or like on an email?
No, an email. I want one piece of paper. It has all of
groups, how many people
all of you. That makes sense?
Yeah, but how many people are in the group?
Let me check how many of you in the course. That's a very important question. So I have 35 students in the course. So pretty much I'm gonna have in the group
3 people would be good.
1 second. I'm gonna have 3 people in the group. If I make it a big group, then some people will be hidden in the middle, and I don't want that. So 3 of you will be in the group. I know that we have 35, so end of the day there are 2 will be working together, but it's still fine. Okay. Any question so far? Somebody's asking question. Let me see who is asking me a question. Yes, because this is the course syllabus. Yes, it's still going to be assigned into a group because 10% of your course is going to be a project. Yes. That's Christopher. Can you repeat what we have to email you? Yes. So basically, I want all of you who are really attending now with me to make yes, the Google Doc, and you assign yourself inside the Google Doc, say that I would like to be I requested access. So I would like to be assigned or I would like to be picked. So you say pick or assign. you will make, you know, the right sign in front of your name. Okay?
So where is the Google Doc?
Yes, you know, I think one of you here, the doc is view only. Oh, that's true. Can you please fix it? Change setting, that's true. Yes, now I can go in there, yes. But can you help them to, oh, it's just say view only. Yeah, I can right now, that's fine. Thank you, Xiang. So, you know, can you please use it? The link have been shared by your colleague, and, you know, yes, I see 2 of you already have something. So you guys will work on this, you know, and it should be easy to fix, okay? Anyway, back to the, one second, back to the lecture. Okay, so my grade scale, I didn't invent it, you know? That grade scale is coming from Cal Poly letter into the Blackboard. So A is 93% to 100%. And A minus is 93% to 90%. B plus is gonna be 90% to 87%. B is gonna be 87, 83%. And B minus is 83 to 80%. And C plus is gonna be 80 to 77%. If you get less than 60%, that means you failed the class. Okay? Now, the topics we're gonna cover in this course. We're gonna cover a lot of actually of topics. We're gonna cover the Verilog modeling of digital systems. We're gonna cover the Verilog modeling of the digital systems, okay? And that's gonna be the structure modeling, the data flow modeling, and the behavior modeling. And after that, we're gonna go ahead and describe the combinational circuit using Verilog. And this is really easy practice if you very good and solid, you have a solid knowledge from the 2300. Description of the combinational circuit using Verilog, metastable state and the setup and hold time and asynchronous input maximum clock rate and the clock skew that will be also covered in this course. Description of the sequential circuit. So that means we're gonna turn it back and revisit our 2300, but we will look to it from the coding and Verilog perspective. So we're gonna look to how to describe finite state machine, how to build a counter using Verilog, what is the difference between synchronized counter versus asynchronized counters, and synchronized reset versus asynchronized reset. And then, you know, we're gonna cover the definition of the registers, different type of the registers, which is starting from the serial input, serial output, serial input, parallel output, parallel input, serial output, and parallel input, parallel output. And also we're gonna cover the barrel shifter as one of the possible registers configuration. We're gonna describe also how can we build the flip-flop based on the excitation and characteristic and the two-stable perspective. Then the topics we're gonna cover also in this course is the FPGA as an architecture. So what is FPGA? How it does look like? How can you program the FPGA? What programming you need to use in the FPGA? What is items inside the chip we are using to program? What does it mean CLB, which is a configurable logic block? What does it mean IO, which is mean input-output ports? How can you map your design into the FPGA and you make it running on the chip? And you can see the board in front of you here with me. Then we're gonna look to other perspective, which is the RTL. What is RTL? The Verilog language, it's actually, you can break it into two pieces. Set of instructions and commands and syntax are targeting the code will be synthesized by the Vhdl, and you will map it on the chip. While there is other syntax are used and directed onto something called test bench. So we're gonna learn how to write the code will be synthesized, which we call it RTL, and the other code which you would check the RTL before you will synthesize it, which is called test bench. Okay? Also, we're gonna learn how to build data bus, control unit, and the digital system specifications. We can look to also the washing machines, how can you make a finite state machine for it, vending machines, traffic light controllers, and all of these extra things. And if we have time, I will go with you through the serial communication protocols. How many of you heard about serial communication protocol? Huh? Yes. So what did you hear about it? Give me an example of the serial communication protocol.
I2C.
Good. Yes.
SPI.
I2C, as you mentioned, SPI, UART, and then, you know, PCIe, and one second. PCIe, what other things? DRAM, DIMM, and all of these guys are serial communication protocols. Before, they used to have something called PCI, but it has been replaced by the PCIe. Nobody have touched this before, but I can try to give you some information about it that's gonna help you a lot to find your job after you graduated from here. General information. There is no, you know, when I say no room for negotiation, it's not about fighting or anything. It's about that, you know, I will do my best to give you a partial credit. I will do my best to give you the best grade because I want all of you to succeed. But when I say no negotiation, that means there is no bargain. Like, you know, you can come and say, for instance, I'm just giving an example. Oh, I need to give A, but, you know, I'm far from A by this. You have to do your best by yourself to show that you are actually capable to beat A. I will do my best. You have, of course, if something wrong actually in my grade, you know, you are welcome to come and tell me fix it. I'm a human, and, you know, I can fix it for you if it's already a problem from my side. Other than that, I cannot do that much. That's why I said no negotiation. So it doesn't mean a fight. It just means that, you know, I'm restrict kind of, okay? There is also no room for me to say, oh, we did better in this quiz, you know, is there is curving or not? I don't do curving. So I want you from day one to be very, very, very strong and ready for taking any type of exam and questions. Okay, you will cover the materials. I'm gonna record to you. Of course, you know, we are now in the COVID-19 and pandemic. So, you know, there is no shame. I'm gonna cover for this to you. And I'm gonna put all of the possible materials which can help you, but please help me as well and go and check in the course documents. Every week, open the course document here in front of you on the left side and check what I'm adding there. That makes sense? Then exams, we're gonna take it as a closed book, but you know, we are now in the pandemic. So everybody basically gonna be home, right? There is nobody in the top of your head checking whether that you are opening the book or not, right? Yeah, just to make it very clear. But there is a way to find who's cheating. We are in a language, in a programming language, which is mean that, you know, I shouldn't find two programs are identical. There is nothing in the world called, oh, it's by accident. It's a programming, which is the way of thinking. Humans are different. There is no way for two humans think the same thing at the same time. We are not in a quantum field here. We are not entangled. You know what does entanglement mean, right? So entangle means that, you know, if you have a particle, another particle, they don't know each other. For a reason or other, they are doing the same exactly motion at the same time without having any relation. That's called entanglement. So we are not entangled here. So any type of cheating will be immediately reported to the university to take a further action. That's also not scaring anybody, but I'm just trying to tell you the rules, okay? The exam will be in a grade scope. How many of you try or heard about grade scope?
I've used it before.
Can you say it again?
Grade scope?
I've used it in summer.
Sure. So grade scope is how it works. I'm gonna put a folder also under the course documents before the exam with a timer. When the time starts, it will give it to you. So you will have a PDF or doc format. you will fill it into the spots. I'm gonna leave it for you, and then you will go load it into the grade scope. I will grade it, so you will be able to see your grades. And if you have any problem with the grade or a specific unit within the non-negotiation, I can help you for sure, and I can clarify it as well. I will leave notes for you, which might help and support you to understand whether that you have a problem or not. Sometimes I write that's a great job, wonderful, and so on, because you guys deserve it when you are doing a great job. If you are making a mistake, there is no shame. I can help you and direct you as well. Make sense? So the grade scope, you will be monitoring after I grade how I already broke up the grades and which pieces are gonna be. I will do my best to break the grades between the portion of the questions so you will fully understand what is exactly your grade. That makes sense? As I mentioned, any kind of mirror solution will consider cheating with intensive action against the participant of this practice. Okay? I'm not gonna remind you the integrity and the academic integrity, and you have to be sure that you have to be honest with yourself. You are going to the industry by yourself. You have to go work by yourself, and then of course, I'm 100% sure that all of you will do the great job, and all of you will be in a very good position. But don't forget me, okay? Anyway, just don't forget to say hi. Any other questions? Do you have any question for anybody who have a disability problem or so on? I'm more than welcome. You send me email privately and I will take care of it. And there is no shame. Normally my exams, I give it not like 1 hour or so. What is a mirror solution? Mirror solution, that means, I told you here's a finite state machine. Go write it using Verilog. You will use the same name of variables. You will use the name of the process, or the always block. And then you will sort them the same thing. And you will use the same test bench cases and the same name of the files. That's called mirror solution. That means both of you were doing the same thing at the same time. When we say exam, that means everybody take the exam by himself. When we say a project, you work in a project together and you will get the same grade, or it depends on the contribution. Okay.
So for the exams, do you send us the questions and then we solve them on paper and scan them?
Or you solve on them in a computer or iPad, like I'm doing. Sometimes I will be writing iPad for
project, right?
What I say?
Like we solve them on the computer and then we send you the file and that's it, right?
You will put it in a grade scope.
Oh, okay.
Load it in a grade scope. I'm gonna forward to you the instruction of the grade scope before the first quiz. The second thing, normally the exams before the pandemic was like what? If midterm is like maybe 1 hour, 15 minutes, right? If it's quiz, like half the time of the class, right? Something like this. But for me, I might give you the exam to be 2 days. So you take the exam with yourself at home. I mean, you are at home and you will study, you fix, you see what you need to do in 2 days, and you will just load it into the grade scope before the time clock will stop. The grade scope will tell you that you can upload up to certain time, and that's gonna be the time window from the time you start the loading until the time you just finish and close. Yes, thank you. So you will have time. I'm sure that all of you under stress, even the professors also under stress. It's a big problem. It's a worldwide problem. No. So you're gonna take the thing from the Blackboard. Let me show you. So previous exam. Let me find you. 1 second. Stay with me, and I'm gonna show you something. Maybe what we can go Blackboard and see summer, for instance. Just an example, right? So in the summer course documents, so you will find midterm 1. So you will find something like this. Okay. Then you click. You will find here the exam in a Word format, the midterm in the PDF format, and then instruction how can you use a grade scope, and then a video telling you when is the exam, recorded by my voice and saying, hey, what you need to do. So that's gonna be completely fair for you to check what is going on. So maybe I can open one and show it to you. It's not a problem, So normally, my exams I put here, like in the beginning, you put your name and the Bronco ID, right? And then, you know, you go ahead, I tell you how much time. So basically, you know, for instance, for them, I said from 8 o'clock in the morning till midnight of that day. So you have one entire day working, almost one day. You are working on solving this problem. You know what I mean? Then, you know, please pay attention to read all of these sub notes. As one of the things I cannot take it is to give me answer without why. So this is something you will find in your documentation all the time. Show all your work. Answers without supporting work will not be given credit. You will find this in every single exam, in the beginning of the exam. So pay attention while you are writing your name and your Bronco ID to read the instructions carefully. That makes sense? Then it will state it for you how many questions for an instance. And then, you know, look, I put here the question. I tell you what is the number of points you're gonna get out of the question. And then I leave you a blank spot. You will answer there. Then, you know, I give you a second question and I give you the how many points you will have. And then, you know, I will leave you blank spot so you will be able to answer there. Then the same thing for the third and fourth and fifth and sixth. So you will be confident and know if you answer this question, how much you will get. If you don't, how much you will lose. Then after you finish doing this, you will take this PDF and you will load it to the assigned place in the grid scope. That makes sense?
Professor?
Yes, sir.
In the future, will you be giving them as a PDF document or as a Word document?
What do you mean by? You
Because
mean like that?
PDF, it's a little harder to edit.
Word and PDF, it's up to you. You take it to Word, you take a PDF. End of the day, you have to submit it as a PDF for the grid scope. Because look, there is an instruction on how to upload document to grid scope. If you open it, it shows you what exactly you need to do. Look, and even it shows you how you can completely make it very clear for the instructor like me to read your answers and give you the deserved thing. So you like it, thanks a lot. So see, you know, if you have an iOS devices, what you need to do, if you have an Android device, what you need to do.
How long does this process take? Like, so we can anticipate.
What do you mean? The grid scope? How can you do it?
From your experience, how long does the upload take?
It takes like seconds.
Seconds, I believe.
Okay, thank you.
A few seconds. But also, let me give you an example. Be sure to load your answers before the gate will close, right? Let's say that I said midnight, right? Where is it? I have it somewhere. Scheiße, I'm sorry. So I have it somewhere here. Just give me a second. Yes, give yourself like a 10, 15 minutes so you will be able to deal with any problem might happen. So one of the problem might happen, which I need to tell you about, which is very important. Guess what? The most critical problem, most of you actually have it. I mean, not you, I mean, in general, students, is basically, you know, you don't want to load the same number of pages. No, you have to load the same number of pages. So for instance, you know, here, this exam in front of you, how many pages it is? It's 14. So you have to load 14 pages. So the PDF, you will go and put it on the grid scope. It has to be 14 pages. Why? Because there is an AI model, artificial intelligence model. It will look to the blank area and the question, and then, you know, I give the answer model to it, and it automatically grade you. Then I go manually after it finished, and I start grade you as well, to be sure that, you know, the machine didn't do bad things to you. That makes sense?
Yeah, that makes sense. Quick clarification.
Sure.
So you said we need to maintain the same format that you have. So we can't take away any of the empty space if we want to register it properly, correct?
Huh?
So we had to keep the same format that you're providing it to us?
Yeah, you mean number of pages. Number of pages was the same thing. So you're gonna fill here your answer, right? Let's say that, you know, you need extra page, right? So in that case, I need to find a way so you can add the extra page. But I will be sure that you don't need extra page.
Okay.
Let's take it in a different way. Imagine that this question in front of you, I give you two empty pages, right? But you answered in one page, right? Leave the second one empty. Don't cut it.
Mm-hmm.
You understand?
Yeah.
It makes sense? It's really trivial. Believe me, it's not that really hard. Maybe you can read about it. I will try to generate for everybody. Did you guys finish? No, still there are a couple of people. Don't forget, please, before you leave today, to put your name in the link that your colleague already, Zhang, already shared with everybody about pick or assign or what. I will do my best to fill your, to follow your requirements. I will do my best. Did you hear what I said? Okay.
Dr. Ali,
Yes, sir.
I was wondering, will you be adding anyone from the waitlist for this class?
How many students we have? We have 35. So are you gonna take the lab as well or just the course?
I was actually wondering about the lab as well, because I did email Professor Yin, and she said she was no longer taking anyone for her lab, so that leaves you.
Okay.
So I was wondering.
Because if you want, you can be course and lab.
Yeah, that would be most ideal.
Okay. Are you in the wait list or what?
Yes, I'm number 1 on your wait list.
Let me check, please. So you are here, right?
Yes, that's
Mario?
me.
Okay,
Mhm.
so Mario, and what about the ISI? Are you here? This is the second one.
You may want to email him, because I did email you for this Zoom call, but I know you're very busy, and I had to get this Zoom code from somebody else.
Can you contact him if you know him? I don't know.
I do not know him.
Okay.
I'm sorry.
I will pass both of you. What's called permission numbers.
I see. So I could get the permission number for this lecture and as well as your lab.
Yes. Can
That's
you
great.
send me another email once we finish this lecture now, and immediately I will reply back. So did you take 300 in the lab, right?
Say that one more time.
Did you take this 2300?
I have not taken the 3300 lab. I want to take.
No. I'm saying, did you take the 2300?
I did. Yes, lecture and lab last semester.
So you finished them. Okay.
Yes.
Okay. In that case, then you are qualified. Okay.
Alrighty then.
Okay.
That's
Thank
great.
you. Do you have any questions so far?
Do we need to order apart the FPGA?
Yes, of course. Everybody have to order FPGA. So let me tell you what is the FPGA. That's a very good question. Why I open NASA for you 1 second? I don't know why. Why I'm doing this? I shouldn't open this one. 1 second. Sorry. I stopped the sharing, right? So anyway, can you see it now? Okay. So you said you need to order the board, right? So we can find together where is the board. There is no problem, right? So syllabus. Before the syllabus, I need to tell you something, and then we go to the board. Okay. So the board.
Professor, I just see your like desktop. I don't see the picture or anything.
You don't see anything?
No.
That's weird. 1 second. Stop. 1 second. And then I share. And then I want to share this. Can you see now? Hello?
Yeah, now it looks good. Yeah, it looks good now.
No, everybody can see. Before I go to the boards, I'm sorry, I will reply to this board thing. Look at the grid center. Do you see the grid center? Full grid center. So you will find your name, And then, you know, in front of you, the quiz, midterm, project final, and the total grade. Here, you can completely look at what, you can look to the progress of your grades until you will achieve the last point of the course, right? So you can actually look to your grade into the Blackboard and see what exactly you need. And then, you know, you can also make a strategy. If you want, you can discuss it with me. It depends how you will reach to the whatever, you know, final grade you're looking for. That makes sense? So everything you will find in the Blackboard, but also the grade scope will be used just for exams. Okay, back to the question you mentioned about the board, right? So let's go back to the lab, because also you guys are attending the lab with me. For all of you, I believe, majority of you attending the lab. So if I go to the 3300 lab, right, you will find also, look, grade center. In the grade center, you will find how many lab we're gonna have. We're gonna have 10 lab plus final project plus total grade. How it's gonna be breaking, we're gonna see it now in the syllabus. Make sense? So you don't need to read this, because, you know, basically we're gonna do the same thing, but in the lab and practice perspective. Monday, Wednesday, as I mentioned. And I mentioned to you about the office hours. And I mentioned to you about the book, right? So the question you asked about the board, right? I work with multiple boards. I work with Vhdl, Xilinx. I work with Libro, Microsemi, Microchip. I work with Altera, which is basically Quartus. But, you know, to be aligned with everybody, we're gonna be stick with what Vhdl as a tools for what? Vhdl as a tools for what's called for Xilinx. And what board are we gonna use? We're gonna use the Nexus 4 DDR. So we click on it. Here's the Nexus 4 DDR. So there is a new one. It's called Nexus A7, which is an upgraded version of the Nexus 4. As a person in front of you, I have a Nexus 4. You have Nexus A7. It's the same. Okay, we're gonna discuss about it, the differences in terms of something called XDC file. This is something you're gonna learn out of this course. So if I click on this Nexus A7, you will find out the price. There's, I think, academic price. So can you see in front of you the DigiLint? Can you see?
Yeah, we can see it.
Yeah.
Yes, okay. So here's the board we are talking about. I want to show you something which is very important. Look into the board, right? So you will find multiple connectors, they're black, right? Those guys called P-mod. It's called what? P-mod. I can write it to everybody here. It's gonna be to everyone in the meet. P-mod. Okay. Those P-mod can have multiple gadgets connected to them. What gadgets can be connected? It can be extra UART, like this one. Can you see in my camera? Can you see in the camera?
Yeah, we can see it.
Yes, this is actually PMON. It can be like this, power meter. You connect a power meter and it checks for you how much power you are sucking while the board is doing computation. Then it comes with a charger. You can buy a charger, so it can be a standalone charge, or you can charge it like what I'm doing now. I'm taking the power from the JTAG. So I program it and power it from the JTAG. You can see it, right? Power cable here. Or you can have external power like there, right? This is like extra you're gonna buy if you want. But you know, I use the bare minimum. Then you have here 7-segment display, which we're gonna learn in the course how can we program it. And we're gonna learn something is called time-maxing domain. Like, you know, there is a multiplexer for timing. Then here's the FPGA. Look, did you see this big chip? I'm actually zooming on it. This one, the one I'm actually, my pointer and standing on it. This is the FPGA. Would you imagine? So the whole price of this board, because of this little itty bitty tiny chip. The rest around it is basically called what? Peripherals. It's a PCB board design practice. You have here USB, you have Ethernet. If we have time, I can show you Ethernet, how it works. And then here the VGA, how the VGA, you know what VGA mean, right? You connect it to the monitor and you can make like a game. Like you can make Sudoku game, you can make whatever game you like, and you can try to program it. Here, bunch of buttons in this area. And then, you know, bunch of switches with LED, and those gonna be the early stage of the programming skills we're gonna learn of the Verilog, okay? The rest here can be any gadget. It can be pressure gadget, it can be a Wi-Fi gadget, it can be Bluetooth gadget, and one of, I think Mario was mentioning that, you know, I2C. Was Mario or somebody else? Who told me about I2C?
It was Danush, I believe.
Danush, I'm sorry, Danush. So, you know, taking credit back, Danush actually mentioned the I2C. Most of those guys are using the I2C and SPI. And there is in the top of the board, there's accelerometers in a way that, you know, and also there is a pressure sensors and temperature sensors. If we have time, we're gonna look to them as well. Sounds good? Anyway, back to the lab. There was a lab here. I remember there was a lab here. Where's my lab? Scheiße.
Professor?
Yes, sir.
When should we have that board ordered?
We're gonna start the lab, but before that, you know, we're gonna be in a lecture mode. So let's say a week from now, we can get the board. That makes sense?
Okay. That's good.
But I know it might be expensive. I just want you to do your best, because this is the best way for you to learn this course. Maybe you can lend it from one of your friends who are already not taking the course anymore, or, you know, they are not into the hardware. I don't know. Maybe you can find deals. I'm not sure if you guys are still in contact with your friend network. So sometime, you know, they even lend it, or, you know, you can take it for a while and return it back. I used to give the students some of mine, but because of this COVID-19, the university is locked, right? So I'm not sure how they will allow me to access students so I can give them board. I don't know. You know what I mean?
Okay.
It's painful. I'm sorry.
Thank you.
Yeah, reality is bad. I'm sorry. Anyway, look at the lab assignments, right? So we have 10 projects, 10 labs basically, with a final project, right? So your final project is 50%. So since we have 15 weeks, maybe those 10 projects will not be 10 labs. They're gonna be 8 or 9. But for now, they are 10. But of course, I have the power of shrinking them to be 8 or 7. Make sense? My God, is crying. I'm sad to hear this. I know. Oh my gosh. Got a poly sending out checks for this? I don't know. If I give you, I will give you from my own. It's not Calpoli. You know, I'm a researcher. I do research with University of Illinois. So I'm a professor here and a researcher in Illinois. So I don't know. I mean, if I find a way, I can help you, but pretty much, I don't think Calpoli will help. Okay. I heard Illinois is sending like packages to students over all the world. That's what I heard, but I'm not sure how. Maybe I can ask. Okay, so every lab, I will record a small video and I put it on the blackboard describing what we need from the lab. Like, you know, build me a circuit, the specification of the circuit 1, 2, 3, 4, 5, 6. Using maybe this component. Good luck, you have 1 week, come back with it. And you're gonna discuss it group by group. That makes sense? So that's gonna be how the video will look like. Also, I might, once I will have the, I will have you guys with, what's called? I will have you guys with groups. I want you to do me a favor, okay? What is this favor? Look, you guys already did a great job, and actually your colleague in the beginning actually did a great job by making this. This is very smart and brilliant way. So once you guys already put your name here, please, I'm gonna do the following. I want you go here in the column E and add your GitHub account. How many of you heard about GitHub?
I have.
Yes, I've heard of GitHub.
Yes, I have.
If you don't hear about it, it's no shame. You know, we are learning. I'm gonna open in front of you. Can you see now in front of you? Is a fast food chain, hopefully. Anyway, GitHub account here. So GitHub, it's a community, it's an open source community coding area, okay? So in front of you here, I'm making a virtual lab. It's called a Reconfigurable Computing Capoli Pomona. This is the group of people, they work with me. Okay? And there, all of the projects I have been done with senior projects and all of these things. If it's a course, look, I go ahead and assign a course group and you will push your code with a video there. So I want you to do your best. Did you hear this? To do your best on writing and sorting your work into the GitHub under this folder. Why? Because when you write your resume, you will put the link of this as an activity you have done. Industry will appreciate this. You will come and say, oh, those guys have a good hands-on experience.
So, Professor,
yes.
Just a question. Do you think that it would be a good idea to like put the projects that we do in this class on the resume?
Of course. Anything you have done, and you will do, it should be added in your resume in a very nice way, very precise way. What was your contribution? Any type of project, even if it's a small thing. Don't forget you are undergraduate, so everything will be appreciated.
Yeah, thanks.
You're welcome. So you guys understand what I'm saying, right? So anything in front of you here with a course number, so those actually a project have been done in the course. Anything else like, you know, compression using PyGZ and stuff like that was senior project. And there is a sponsor here coming from Xilinx. And also, you know, I have my own sponsor coming from Siemens, who might actually pay for the senior projects. So I don't know, let's see. Anyway, so you understand what I'm saying? Like this one, that was a senior project. And IBM and Illinois was a part of it. That also was like, you know, motion controller. That was Xilinx and IBM, for instance, you know. Last 10, that was NIH, National Institute of Health. It was part of this work. Anyway, so back to the point. So I'm gonna create a new subfolders for every single group. So I will need from this link to find your GitHub. Exactly, I have seen a lot of people added their GitHub, which is I really appreciate it. So Xiang and the rest of the people, can you please add your GitHub as well? Before I do any work, I will need everybody to put here pick or assigned. And we have 35 students so far. I have just seen 31. So that means I have even 30. So that means I need the rest of you. So please do your best, even less than that. So I need all of you, please, to put your name under this one. So this link is very important. I'm gonna pass this link now in front of you into the, 1 second. Yes, into the course documents here. So 2300, you are 3300, right? So announcement, urgent. Dear all, please be sure to add your name, your decision about assign or pick, and your bit account into the following form. As soon as possible. this week, scheiße, I'm sorry. This week is your due for this task. Okay, Mohammed. Yes, I'm Meili at cbb.edu. Yes, Meili Finance State Machine, if you remember. Okay. Okay. Now we haven't finished talking about what. So we were talking about the 3300 lab, right? Syllabus. Yes, I will. Okay, maybe I will do it for you. So, any questions so far?
Yes, I understand it.
Okay, buddy.
Okay, so everything's clear, right?
Yes.
Yes, I understand everything. It's good.
Thank you, I appreciate it. So, Anthony was talking about, if you guys would like to have a Discord channel. Actually, I can tell you another story, which is cool. I have something is called Slack. Have you heard about Slack?
Yes.
No.
So Slack I'm using was IBM. Look, I can show you. We have a ton of programs here, like program for robotics and stuff like this. So maybe what I can do, I can make a new channel and create a channel, right? And this is channel, I will call it what? ECE 3300. Oh, shit, I'm sorry. What is going on? ECE? Huh? Doesn't allow me. ECE 3300 for 2020, right? This is the course and lab channel, right? Create. Add all team member, no, add a specific people, right? Then I will add all of you in the course into this channel. Justin, the Slack, so So I will add you, all of you, once I finish this course there, right? And then you will be able to communicate and see how it works. Like all of you can communicate using this. So I will say skip for now, and later on I will add all of you. That makes sense? So you will have that channel, so all of you can know each other, so you can work together. If any problems like facing you guys, we'll discuss it here, and it's gonna be very organized way for knowing what's going on. Then you already have the office hours. I would be more than happy to assist you. And then you already have also the time of the course and the lab. You can ask any questions and I will be more than happy to assist you. So I think we are almost done with the organizational way of the lab and the course for this semester, right? Now maybe we can start talking about what the first part of the course. Make sense? So I'm gonna make it not traditional way of course, like the lecture. What does it mean of this? So I'm gonna write in front of you a piece of code and show you how Vhdl work, and then from next time, which is gonna be Wednesday, I will start giving you the proper slides, and we can go through it. That makes sense? So,
Professor, do we have to download any software to run the FPGA?
Yes, that's basically what I'm gonna do in front of you. So basically now, there is a historical story I need to share with you. So Xilinx started in 1948, 1985 or 86, I'm sorry. When they started the program, they were using a program to program their FPGA, they call it ISE. Okay, so the program was called what? ISE. And then this program was covering most of their chips up to vertex 6. Then they came into a conclusion that, ICE is obsolete. We should actually find a more realistic software modeling which will help us to map the FPGA programming on the board. And they came out with something which is called Vhdl. Vhdl, it's a software have been developed intensively by a team in UCLA, University of California, Los Angeles. And the head of the team is a professor. His name, I can show you. His group is called Jason Kong. Professor Jason Kong made a startup company, designed Vhdl. And then Xilinx bought the company from what? From Jason, and adopted to be their own official software for Xilinx. What is Vhdl is? So if you go here in Xilinx and write Xilinx Vhdl, download, excuse me. So you will find there is a multiple generation of Vhdl. There is here versions, 2020, 2019 2, 2019 1, and so on. And in the top of this, Xilinx is coming out with a new platform which is called Vitis, which is mainly targeting AI application on FPGA. That makes sense? So Vhdl is the one we're gonna use. Vhdl is the one we're gonna use. The one I have, Vitis, that I mentioned to you. Look, that's called Vitis. And then, Vitis embedded platform. Then Peta Linux, if you are using embedded systems, and device modeling using some other stuff for UltraScale Plus and, Ultra, and, what's the other one? Mpsoc. So here's the, let me show you. This is one of the board, which is using the Vitis and also using the what's called the Vhdl. Let me show it to you. This is approximately this one. It's worth $17,000. Okay, that's FPGA used for AI application. It looks like a graphic card. That makes sense, yes, because graphic card is using for computation. It's not for gaming. The gaming is a side job of the graphic card. But anyway, and then there's another one I'll share with you now in a moment, which this one. This is Mpsoc. The Mpsoc, it's very expensive because it has a kind of a multi-core processing, which is holding FPGA and GPU inside the chip. We can talk about this more into the higher order courses like 4300 and stuff like that, not into the 3300, but at least, I'm giving you how it works. This one, for instance, I have two of it. Each one is like $15,000 each.
So, Professor, are GPUs a derivative of FPGAs?
No, GPU, I will tell you a story. So GPU is a kind of like the normal traditional CPU. It has a multiple cores, but those cores are running in parallel. That's why GPU is a graphical processing unit. It has thousands of the processing elements which can do a lot of work in parallel. So it's a parallel platform. While the CPU, it has several processing elements, which we call it cores. So for instance, I11s or I9, you will look at it into how many core of the processing element or the coprocessor inside the chip are doing a process, right? FPGA is completely different. FPGA is like a whiteboard, and you draw on the whiteboard whatever you want in a moment, and if you don't like it, you wipe it off and you reconfigure it again. So there is something that's called fine generality versus coarse generality. And the FPGA is a kind of the coarse granular. It's a type of the architecture. But anyway, we need to be more focused on the Verilog here. So Vhdl, you will download it. My computer is really quite old, so I'm using the 218 Vhdl. But for you guys, you can use 2020 if you have a very good computer, So there is a multiple version of Vhdl. No, it's not Raspberry Pi. Raspberry Pi is ARM processor, which is really quite tiny and small. There is a small versions of FPGA can be holding ARM processor, which we call PINC-Z. So let me, 1 second, let me unplug this and I can show it to you in a moment because I have a cluster of it here in my desk. This one, this is called PINC-Z SoC, which has ARM processor much stronger than a Raspberry Pi with a fabric of FPGA connected to it. And that's called overlay architecture. That's another version. This is actually worth like a $300, I believe, each. I think I have like around 100 of it. Anyway, so back to the point. So if you notice here, look, ISE archive, Vhdl archived the older version in 2018, and then 2018, 2019, and 2019 too, and 2021. For me, I don't have the fancy one, I just have the old one. Don't forget also, the software they provided here, it can be adopted in Windows, it can be running and adopted in Linux. I have a Linux machine here on the other side of the room. I'm using it connected to a big server, so I can show it to you. It has also Vhdl, this one. Can you see it? It's here on my desk. But you know, the one I'm using for the teaching and with you, it's a Windows one. So I go here, I can show you what does Vhdl look like. A second, because this computer is very slow. Hey, dude, open. Scheiße. Not sure what's going on, but I will find a way to open it. Open, please. Thank you. You are mean anyway, so I'm gonna find a different way. Xilinx. Maybe I can open it from here. Oh, it opens, you know, anyway. So I should open it from the other channel. Anyway, so I write here Vhdl 2018. Unfortunately, I have the 2018 too. So look, I'm really far, you know, 2018 too, even it's not there. Anyway, it's in the archive. So it's launching. It takes some time. When it launches, I will just put it in front of you on the shared screen, okay? So look at this. Can you see in front of you? So this is Vhdl. So this is how it works. One of you guys will ask me, is it possible to have a license? Because this is a very expensive software, right? So since all of us now at home, right? I mean, I'm in my office, but you know, for you guys, majority of you or all of you are at home, right? So there is actually a license for students. You can search on the internet and you will find. So if we go together here and we just write Webpack, which is basically Vhdl student license. So tell you the benefits and how you're gonna work with it. And you can search and you find it, that's not really hard. And there is something that's called Xilinx University program, which can help you with their email address when you click in this contact XUP. And they will be more than happy to help you with such a kind of thing. You know what I mean? Okay, anyway.
So just to make sure, that's the only program that we need to download, or
yeah, this is the only program for now we need. Anyway, so let me just tell you the rest of the story. So Vhdl up to a certain level of boards, we need a very expensive a specific license. But you know, A7 or Arctic 7 or Nexus 4 DDR, the one I have, which is A7 version, but you know, not much resources as the new one. It should be running by the student license, so that you don't need any specific expensive license. Okay. Anyway, normally when people actually go and program Vhdl, they have to put in their mind 3 things. Okay, what are the 3 things? The first thing, you need to create a project. The second thing, what type of FPGA we're gonna use to program using this project. The third, what constraint file we're gonna use to map the IO. I'm gonna do all of this in front of you, and next time we're gonna start from scratch, but at least you can get the idea of what's going on. So pay attention. So now, you know, I'm saying create a project. I'm creating a project. Okay, that's perfect. And what is this project is, I will say next. Then I will need to make a project name. So let's say example 1 ECE 3300 fold. Okay, and then I will create a project folder, and this folder will be open here. And from there I can say select, and from select I can say a name, which is ACE 3300 course fall, and then, you know, it created for me. So imagine if I don't have it, it's automatically created. The second important thing, what is the project will be? It's about RTL. Do you remember in the outline, outlines of the course, I said there's something called RTL? So this is the RTL. Those RTL can be written using Verilog, Vhdl, system Verilog, or you can call some ready function from the Vhdl, which is called IP. Look, there is an IP integrator, generate IP and run synthesis. So for now, we are not taking something ready, but we are developing something by ourselves. That makes sense? Then you say next. Now, the chance of adding the board. Some of the times you will find the board name and you select it. But because this is a very old version of Vhdl, so it doesn't have the board name, so you just say parts. Then in the back of the chip, in the back of my chip here, I should know the name of the board, which is the RTX 7 whatever. So let me find it here. So can you see in front of you, there is a box on the board here on the box, right? Like the one that says Xilinx with the sign, red sign. Can you see it?
Yes.
Okay, so in there, you will find a name, which has a very long name, XC7A something, right? So this is the one we're gonna write here in the search. Look, I'm writing in the search, you look in the camera, XC7A. So now we are decreasing number of chips, 100 T, C, S, and then, you know, have you noticed it was minus C, right? It's not minus C. I took the C as a package name, but minus here is the speed grade. So we take here -1. Can you see? If you look to the camera and you look to the screen shared, you will find both of them there, right? Then you will find it's telling you what element inside the FPGA chip you are actually selecting. Did you see that? So it's telling you, I have input output 324 pin. I have available input output ports. I have how many lookup tables? 36,400. I have how many flip-flops I can use? 126,800. I have 135 block RAM. I have 240 DSPs and have one PCIe if it can be happen. And I have a bunch of the MMCM, which is basically the phase-locked loop channels. And then, you know, operating voltage is 0.9 volt. So less than 1 volt it can operate it. And then, you know, I have a maximum voltage for the chip, which is 1.05. Then I say select, finish. Sounds good? So what I did, I created the project. I decided what chip I will need. That makes sense? And now I have here source. But before source, I need to add something that's called constraint file. So let's go ahead and do it. So I would say add source. And in the add source, I collected on the right. Can you see everybody? You guys are following me, right?
Yes. Yeah.
So add source under setting. And there it popped out for me 3 different categories. You notice? It has add or create constraint, add or create design source, add or create simulation. What is those? Add or create constraint basically is telling you what is the IO names, like, you know, the UART and all of these things, right? Add design, that's the RTL, the thing you're gonna synthesize. Add or create simulation, this is basically the test bench. Sounds good? Okay, so now I'm gonna say add or create design source. Sounds good? I don't have add and create design source. I will go back and say add constraints first. Every single chip, it has a constraint. Every single chip, it has a constraint. So I would say add, and then I create it, and then I will call it what? Nexus for DDR, just a name. And this is actually, the extension of this file is .xdc, okay? In the ICE, the older version program, that file was using something called UCF, but now it's called what? XDC. So I'm gonna go ahead and say, okay. Then I say finish. Then now, if I go ahead and under the constraint folder, I will find it there, and then I will click on it. I will find it what? Empty. I just created, right? So what I need to do, I will go back to my Google, and I say that, you know, Nexus for DDR what? XDC file. So I'm searching for the what is inside this XDC file. I will go in a GitHub, the one you guys will build, and then, you know, and you will go ahead and just connect and take all of this. The language is used for describing all of this in front of you is called Tcl File, Tcl File. It's a version of the Tcl File. It's a program language used for describing constraints of a chip. It's we're gonna just take it for now as it is. We're not gonna learn how to go ahead and, you know, modify it later. I will tell you how can you modify it. But for now, we need to take a copy because this is actually the factory copy from Xilinx. Take a copy here and you turn it back to the event. Then Control V, and then, you know, I already added everything. That makes sense? So far, it's easy, right? We will look to it and see what is written there. So first of all, you have here the name and all of this yada yada, but then there's something in front of you, it's called clock signal. So there is a crystal inside the chip which used for what? Generating clock. To generate the clock, you have to what's uncommented, these 2 lines, and the clock name will be here, clock 100 megahertz. So the maximum frequency out of this is 100 megahertz. We're not gonna use it now, I'm just telling you. Then, do you remember when I shared with you the board, and I said there is 16 switches in front of you, look at the camera. There are 16 switches here, right? I'm pointing to them, right? Those 16 switches in front of you, the name of them are holded under the switches. Did you see those? I already highlighted them. Make sense? And it's called what? Switches. The one you will use, the one you will uncomment, the rest you will comment it. The comment is basically like this. Hash, and then, you know, you'll write whatever, this is commented. Sounds good? Now, LED, we mentioned in the above line of the switches, there is 16 LED, right? Those 16 LED in front of you are represented there. While there are 2 LED, one is called 16, one 17, it has 3 different degrees of light, BGR, which is the blue, green, red. So those guys are colorful LED. Where are those? Do you see those LEDs are making different colors? Those are the one associated to those couple of lines. Then you have the 7-segment display. Here's the 7-segment display. All of these guys, the 7-segment display, are associated to those in the physical layer of the board, the LEDs, the 8 digits in front of you. Then you have a bunch of buttons here, and I believe there are 5 buttons, and those are the 5 buttons in front of you. And then you already have here headers, which is the pmod. How many pmod we have? 1, 2, 3, 4, 5. So we have 5. A, B, C, D, E, and those are 5. Then the VGA connector for this VGA and how we're gonna communicate with them. And there is SD card here in the back of the FPGA you can find. There is accelerometers, as I mentioned to you on the board, and those are using SPI. And then and then there is a temperature sensors using I2C, as your colleague mentioned in the beginning. And there is also a microphone you can connect it and work with. And there is audio PWM, pulse width modulation. We're gonna talk about it later. And interfaces to the UART, which is called I2 interfaces RS23. And there is also a USB working with HDMI. And there is Ethernet. And there is a flash communicating using SPI interface. So that's basically the history of the physical part. So this is the first steps you have to do. You create a project, you create the constraints, and you will spill out all of the information coming in the XDC, and you will find an internet popular and accessible by everybody. You have any questions so far? Okay, now I'm gonna make an example to see how it works, and later on we're gonna start talking about the language. So create, now I'm gonna create the design. So what is design? So next, create, and here in front of you, the type of the files I can create vary from the Verilog, system Verilog, Vhdl, and there is something called Verilog header if you are building a library, or memory file if you are flashing a memory. So pretty much, we are in now Verilog language, so we are using Verilog. And I want this file to call what? What should we build from your point of view? Let's say we are gonna build multiplexer. So mux. I'm just calling it mux. Then okay, then finish. Vivado is helping me with a very nice feature for adding the names. But I don't need it for now. Later we can use it. I just open it. So it takes some time to generate it. So did you see under the design source, it popped out something called mux, right? So this is something you need to learn. While you are writing code, you have to be very organized in a way that when you will visit the code back in a week or two, you will still remember what you already have accomplished while you're writing this code. So that's why you have to write the design name, the time, what was the device you used, what is the version of the tools you use, and the briefly description of the piece of the code you are writing. So the hierarchy structure part of the describing the file in the Verilog, that file we call it what? Module. We call it what? Module. And the module, when you write it, you have to call it module. The name of the module will be the name of the file. And then you will say in module, and then you have here the parentheses opening and closing for a reason. Okay, so what we should have inside here, we should have the list of the possible input and output of this circuit. So the circuit is a multiplexer. If you remember from the 2300, what does a multiplexer should look like? Somebody can tell me?
So you should have your inputs, your selection, and then your output.
Exactly, Mario. Thanks so much. So let's make a very easy example, which is the 2x1 multiplexer. So what we're expecting is 2 input and 1 selector, because the selector is the log 2 of number of inputs, and 1 output. So we can say the following. Inputs. So we have 3 different types of the definition of the ports in the module. We have input, we have output, and we have in-out. But there, we don't need in-out. We just need input and out. So we need input, right? Let's call the first input of the multiplexer, I will call it X. Then I need another input, which is Y. Then I need what's input also, which is called select. Then I need one output, which is called output, right? But this output, in the older versions of the Verilog, you should actually spell out what is the type of the output will be. Now, the default of the output is wire. It's just a piece of wire. So there is something is called data type in the Verilog. We're gonna learn next lecture. What does this mean? It means the following. We have output, we should have register or wire, and later on we will call something called procedure task. I'm not gonna go too much in details, but it's called output and it's gonna be wire. But my notation in this course, please follow my notation. Don't leave it like this. You have to say wire or register, so it's gonna be wire. Now, in the beginning of the outline, I mentioned to you clearly there is hardware modelings in the Verilog. There is one is called structure modeling. There is one is called data flow, and there is one is called behavior modeling. So behavior modeling, you are describing the behavior of the circuit, which is like you are writing C. While you are in the structure, you are building by AND and OR, while in the data machine or the flow machine, you are using the concurrent statement is called assignment. So we can build our circuit using one of them. So one of the way is to build with using NAND or AND, right? What is this? So basically you can come and say, I have a wire, and this wire is called temp1. And I have another wire, it's called temp2. Why? Because in the normally, if I have a multiplexer, I have the first input ended with select. The second input ended with the not select. So also I need another wire. So I can say wire temp3. So I can come and say not what temp3 with what select. Then temp3 is the not gated of select. Then I will take temp3 and I ended with what? With X or Y. Let's say ended with Y, and it will produce temp1. So temp1 is going to be with what? X and what? Temp3. Then I have another end. The output of it is going to be temp2, and the two inputs is going to be the Y with the temp with select, I believe. I think I made a mistake, so I will fix it. So this is select. Then the two outputs of AND will be OR. So I'm gonna have OR, and here we're gonna be up and temp1 with temp2. What I did in front of you, I built the circuit using structure modeling. I built the circuit using structure modeling. Okay, so let's move forward to see whether this circuit is really quite correct or not. I have no idea. Maybe I'm actually making any yada thing, right? So the need for me to check whether this thing is correct or not, to build something is called what? Test bench. So I'm gonna go here and say add, create a simulation, and from there I say create, and it's still Verilog, and I will call it what? Max_TB, which is stand for test bench. Then I will come and say finish. In a test bench, you will do something very interesting, which later on you will learn intensively, which is called instantiating blocks. So now I will look into the simulation and I will go into the max temp. I found out there is no parentheses, nothing there, and I need to start filling it. So I have to instantiate. Basically, this test bench is testing what? Testing whether the multiplexer is correct or not. Do you agree? So in that case, I have to call the multiplexer. But I can call the multiplexer with any name I want. So I can instantiate infinity numbers with a different name. So in that case, I will give it name and say temp, and I say mod 1. So this is my instantiation. And there, I will start calling my input-output ports in order. So I have X, I have Y, and I have select, and I have OB. Okay? This is the block. But I need to connect it to wire so I can start propping and pushing like what you were doing before in the 2300 lab. So I'm gonna make a bunch of wire and registers. Normally what we do in the design, we call the inputs wire and the output registers. So, you know, in the test bench. So say reg X, Y, and since X and Y, they're the same size, which is 1 bit, so I make them in one line. I can do this. And then I can come and say wire OB. And also this, I can make it select like this, because 3 of them are 1 bit. Then I can change their name to be different. So I can call here, I'm sorry, I can make it TB, and I can put it here. TB, X, TB, Y, TB, select TB, and output is gonna be output TB, but I don't have output TB, so I'm gonna make it here output TB. So far so good. Now I need to push the input and output and the select to see the output. So I have to make something that's called initial block. So I'm gonna show it to you, initial. And I can call this what? First test bench. There, I can come and say X is equal. I can make it with the equal. And I say X is equal what? 1. All of this, don't worry, don't be afraid. They're gonna be covered eventually. I just want to show you the hierarchy. And you know, let's say Y is 0. Is 1 bit and 0. Okay, and then you know we can come and say here select. Of course, you know it gives me error because there is nothing is connected called X and B. It's basically just could be X and TB. Okay, now this is also an error, and then from there, and B, 0. And after maybe 10 nanoseconds, we can have a different setup. Maybe we can have selected we change to be 1B1. And then, you know, we can have maybe 100 nanoseconds to wait for something. And then I will come and say, close your test bench. All of this we're gonna learn in details soon. So what we have now, we wrote our first test bench, which is wrapping around this block. And what we did here is called instantiation. So that means we call it, which is like a subroutine. Remember subroutine in the C language? You call something inside the program and you have it in multiple names. We would like to see whether this thing is gonna work or not. And I made a mistake. Hopefully it will not work, so I can tell you what is exactly will happen. So here, run simulation. Now the test bench look, I want to show you something. In the design source, there is a sign in front of you here, right? This is called, it's have been treated as a top module. Look, it's called top module. So you promote it as a top module, sit as a top. And for the test bench, what is the top module? It's a test bench number 1. If you have a multiple one, you can pick one of them to make it sit as a top. So you go here and say run simulation, and let's see what will happen. It passed. So if I look at it, look what happened. So if X is 1 and Y is 0, if select is 0, so it will select what? It will select Y. And Y is 0, so basically the output is 0. After 10 nanoseconds, I changed my select to be 1. So pretty much it selected X, and X value was 1, so now is 1. So now you understand what I'm saying? So I build an environment describing a circuit acting as a multiplexer, and I tested. Is this the end of the game as a designer? No. So you will stop the simulation, and after this, you will go back to the last stage before you process, which is born into multiplexers. So the multiplexers, it has X and Y and select and output, right? From your point of view, X and Y and select can be acting in the board as what? Somebody can tell me. Can be like LED or can be switch?
Switch?
Switch, exactly. Because you are feeding the X with any value you want. You are feeding the Y with any value you want. You are feeding the select with any value you want. What about output? Output will be what?
LED.
It will be LED. Exactly, thank you. So what we need to do, we need to turn it back to the XDC files, and we can play a little bit. We come and say, I need 3 switches, 1, 2, 3. The first switch, it will be X. So the name will be changed because it changed in the file to be X. By the way, this language is the case sensitive. That means if you have a lowercase x, is different than the uppercase x. The lowercase y is different than the uppercase y. Is it clear? So I have to be sure my multiplexer, it's here is spelled as an x lowercase, so it's x lowercase. The second one is y lowercase, and then you know the select also is everything written in the lowercase, right? Then I go in my output here. The output is basically, output here is everything is lowercase, so we're gonna pick the first LED, for instance, to be the output. So gonna be here. So we are mapped 100% the input-output ports of the multiplexer into the XDC file, and we are ready to load this in the board. Let's do it till the end, and that will be the end of the lecture for today. So we have to go through process. So can you please, guys, pay attention to the flow navigator? You will find out that there is here synthesis, and you run synthesis, and there is an implementation, and there is generate bit stream. So we're gonna go in a run synthesis. So I push the run synthesis, and it should take some time to do the process. You can notice this in the top right of the window with this greenish thing is moving in a circle, or you can also notice it under the design runs and the name, and you will find the green rounding moving, right? Can you see this?
Yeah.
So passed. And in that case, we can go into the second in a row, which is called optimization. If you noticed, I want you to have a look. You will find here number of resources we use in the design line. Can you see my cursor? my cursor is standing in the lookup table. So this multiplexer cost me something on FPGA called lookup table, just one. And there is no flip-flops used, no BRAMs or URAM or DSP have been used. So in that case, you say the second in a row run implementation. Later on, I will teach you something which is called embedded logic analyzer, which can be added into the flow, and it show you while you are playing with your board on the screen, there is an analyzer coming out and popping out the results in front of you on a window. But anyway, we are running now the second in row, which is called run implementation. It takes time. My computer is not like super fancy.
Professor?
Yes, sir.
Just so that we can kind of compare to what computer we have, so that I know like what version to download. What processor do you have?
I mean, no. My problem is not the processor. My problem is the hard disk. It's completely full, and the new generation Vhdl is taking a lot of memory resources and a lot of hard disk.
So if we have an SSD with plenty of space,
SSD is good. It's good. It's completely good. You know, I would recommend you to go ahead and do it. You know, it's completely good. You know, it's better for you to run with the newest version. That's basically what I would recommend. But for me, you know, I can deal with it. I can even hack the system. So you don't need to worry that much, you know.
Yeah, okay, thanks.
So implementation came after the synthesis with conclusion say, you know what, synthesis was correct. It just cost me one lookup table. Did you notice this? It came here, right? And inside the implementation, there is a multiple things. There is like place and route, and there is fixing the place and route, which is basically you guys, when you're routing with wires by your hand to connect between the switches and LAD on the breadboard. So now we are completely done, and we can actually open and see what is inside connected, if you want, in open implementation design. So if you open this, just wait a second. And it tells you even roughly total power is consumed, 1.132 watts. You know, it's giving you an estimator. Definitely, if I hook this into the system, it can also compare the value, whether that, you know, there is a power have been drawn is the same amount or not, right? So look in front of you is giving you the info about your little itty design, like report, how much resources and stuff like that, power, how much the power have been broken in, like, you know, signals less than 2% of the whole entire systems in a dynamic fashion, logic how much, and the rest how much, and the IO devices how much, and all of this hierarchy things. And timing is very important. We're going to learn about timing, but this is a combinational circuit, so there is no big issue for one lookup table. As the smallest element inside the FPGA, I don't think it will cause a big damage. So here you can utilize, check the noise, DRC on the left side of the board. So now I'm going to go into schematic. Maybe I can see what does the schematic look like. Here is your circuit. Is one lookup table and 3 inputs and 1 output connected to the OP as a LED, and X and select and Y connected to the input through the internal buffers. So that's basically what exactly happened inside the chip. Now I'm gonna go in the generate bit stream, which is opening the door for me to load it on the chip. So let's see what will happen. It's a running bit stream. You know what does bit stream mean? It's taking the code and generating on and off switches, binary numbers. So it will map on the chip and turn on the right lookup tables and hook it up with the three switches and the one LED we're gonna have on a board. And momently we're gonna start demonstrating that. So the flash on the board, it has a program which is a demo program coming from the DigiLand. You can see this is something from them. Once we start mapping, eventually everything will be magically changed. So let's see. So you can see on the shared screen that everything is done, right? So now we are ready to load the program on the chip. So we say open hardware manager. From there, we open target and we check the cable. Hopefully the cable is working. Sometimes it doesn't work. I don't know if it will work or not. Let's see. It found the chip on the board. So it takes some time. So I can come and say program device, and magically it generated here in front of you with the pass on the hard disk end with mux.bt. So it's coming from bitstream. And of course, later on, you don't need to rerun all of this. You can actually call this bit file and just like generating it and putting on the board. So now I want you to pay attention to my camera while I'm pushing the program button on the screen. Okay, everybody ready? So I'm gonna push the buttons, everything down here, and I want you to look what's going on. What is it going on in front of you? The board have been programmed, and no longer the program that DigiLand give us on the board exist. But we said we have three different switches. Do you remember? So we have X and Y and select consecutively from the left to the right. Can you see my finger on the camera? So if I push X with 1 and I push Y with 0 and select 0, nothing of this LED will be turning on. Do you agree? But if I push the select on, so I selected X in this case, and LED turned it on. If I flip X to be 0 and Y is 0 and select is 1, so nothing is coming out unless I push select with 0, which is proving that the test bench did a great job and the realization in the board is matching what I tested. And that's pretty much what we're gonna do for the rest of the semester. Do you guys have any question? Do you guys have any concern?
What's the time frame you said we should be looking into getting our FPGA boards? You said about a week?
I think it should take a week for shipping.
Okay.
I want you guys to practice. We're gonna practice even, I'm gonna be writing code in front of you live, like I'm doing in front of you today. So we're gonna take a theoretical part and we go apply it. And then, later on I will assign a lab. You will do your assignment in the lab and you come back so I can assess and give you a grade. Mm-hmm. Then there is a theoretical exam, as I mentioned in the syllabus. Everything will be found clearly in the Blackboard. Is this available for Mac or something similar? I have a Mac in my home, and this Vhdl or FPGA is graded as a military tool. And Apple, they have their own policy of not supporting any military application or activity, as they are considered themselves peaceful company. So the only two operating systems supporting such a kind of program without any lack of support is Windows and any different type of open source or source Linux. I made my own hack and I set up Linux on Mac, which is something not that people seen, it's really rare. And I'm running it there. Some mistakes happening in the audio systems and I fixing it by making my own driver. But that's really too much. That's a couple of courses together beside your course material and other activity that would be too much on you. Any other questions or any concern? One of the way to do it is to maybe have a virtual operating system. Do you remember this VM? Yes, exactly. Any, you know, whatever. I'm telling you, for my case, it's you can make dual boot as well. I make a dual boot as well. Yes. Will you be uploading this video somewhere? It will be uploaded under the course document, as I mentioned in the early of the day, with week number 1. So week number 1, it will be consistent Monday, Wednesday of this week. Do we have to use Nexus A, or if we have Nexus 4 is fine? For sure, any Nexus you have is perfectly appreciated. Myself, I have Nexus 4, you have Nexus A7, it's similar of Nexus 4. The difference between of them is a bigger number of resources than whatever I have, which is not that critical for the educational purposes. Any other question? Any other concern?
Just to clarify, the Nexus A7 or Nexus 4 are both acceptable?
Of course. If you have any of your friends who actually passed the course, he doesn't need it this semester, go ahead and take it from him. Any other question? If everything is clear, give me a thumbs up. Or say yes, or yes. Somebody just give me a thumbs up. Okay. Thank you, Michael. Thank you, Mario. Thanks, everybody. Thank you, Stephen. Thank you, Luis. You know, thank you, Kingston. You know, Ryan, Sean. You know, thanks so much for all of you guys. I wish you a wonderful day. Please stay safe, and God bless you. Mario, I'm gonna reply back to you with the permission numbers and for both the lab and the course as well. And
Thank you very much.
And you know, I appreciate, of course, you know, your attending of this course, and I appreciate everybody attending this course in my group here. And please don't hesitate to ask me any questions if you want. And you know, be sure for all of you to reply back to the link that you know your colleague already generated with the GitHub and the rest of the stuff. Make sense? So thanks so much. Have a wonderful day. Stay safe. God bless you.
Thanks, Professor.
Thank you. Bye-bye.
Thank you.
Professor.
Thank you, Professor.
Thank you. Bye-bye.